Hey everyone,
Hey,
how's it going?
it's fine. It's going good. How are things at your end?
Pretty good. My hair is an absolute disaster today, but it's fine. Hey Vlad,
Oh,
how's it going?
hey, not bad. Good to see you guys.
Wait just a few more minutes because it's still a bit early. I imagine Kevin will show up and then we can sort of get started. I noticed that the chapters itself this week were a bit short, so I went ahead and tentatively just posted my notes through chapter 16. We'll see if we get that far. But chapter 13 was the main bulky one from what I remember.
Zachary, I would like to congratulate you on the PR merger, the integrated MS AMP one that you
Oh,
guys did.
thank you.
Yeah, it was a huge undertaking, as I suppose.
Yes and no, actually. It was actually relatively straightforward. From their API. The reason why it took so long was to really just run integration tests
Hmm.
and make sure that MSAMP was actually working properly.
Okay.
Um, because the thing could have been merged in a week, but what I wound up finding is MSAMP with Transformers engine doesn't always work very well. Like, at least from the losses, they were radically different within the first few epics, and accuracy was a bit degraded too. So most of it came from just like, okay, well, if that's a thing now, I guess we'll separate the two and figure out why Transformers engine doesn't particularly work very well. Um, but thank you. Yeah, I know it's been something that people have wanted for a bit. And I finally had some time to really look at it. So,
Hmm.
hey, Kevin.
Hey Zach, how's it going?
Good. How are you?
Pretty good. Hey Vlad, hey Mayank.
Hey, Kevin.
All right. It's 8. At least the usual people are here, so we'll go ahead and get started. As I sort of mentioned earlier, we might get through chapter 16. I think I have 16 or up to chapter 16. We'll see. We are nearing the end of the book though. So with this week off, I might just say get through the end of the book by the time we meet up towards New Year. Because the last few chapters aren't that bulky, at least from my notes and looking at what I actually found interesting in them. So I think we can get through 6 chapters in 2 weeks. But let's go ahead and focus on what's new here. So, sort of building off of the tail end of chapter 13 and how do you write comments, or chapter 12, chapter 13 sort of gives us a principle of what it means more when they say, like, write good comments. What is a good comment? Uh, and the general tagline for that is comments should describe things that aren't obvious from the code, which, we talked a bit about earlier of, yes, don't say this is a for loop. This is, taking the first index. Those are things we know. But a good comment could be like, if it's an ambiguous iterable that we're going over, like this is going over the data loader specifically, or calling something in the data loader. That's a bit less obvious and a better way to do that. So on the importance of comments, it talked about abstractions sort of provide a simple way to think about something. But when you're looking at code, code can hide abstraction exceedingly well, right? I know we're going back and forth to fast AI over and over and over again, but it's a really good example of abstraction and over abstraction. It provides you with a really simplistic interface, but that simplistic interface hides a bunch of stuff happening, on the back end. And so you really have to rely on comments to simplify this, because you want to keep a simple API. Inherently, that's a good thing. You just need to back it up with the documentation, be it either in comments or in documentation, to make sure that users can understand what the code is doing. More than like, this is now getting into like nitty-gritty beyond user details. This is people who are actually investigating your code and wanting to learn more about how it works, which is sort of a different level of a user now. And basically it gives us a relatively simplistic definition of what a comment should be. It's a simpler, higher level view that should allow anyone, specifically a developer though in this case, to understand the abstraction without having to go through a chain and digging through what the heck's going on. Because you can abstract something behind 3 or 4 different function calls, that's fine, as long as we explain what those things are actually doing. And then it sort of talks about you should pick conventions. Ideally, you should adopt existing conventions from similar languages or projects. This makes picking up your project, reading it, and understanding it a lot simpler. Examples of this with Python would be coming to a standard for documentation strings and how documentation strings are written in the Python code. So that could be like your Google Doc strings, that could be your NumPy doc strings, NumPy, depending on your forte. These sort of standardized ways of writing things, because even if it's not convenient for you, it's used by everyone else, which at the end of the day, from a user perspective, that's what you want. You can deal with the headache of 1 or 2 things aren't quite, the most convenient for you to write if everyone else benefits from it.
So, what comments do you prefer? Like method level comments, or like doc comments, or single line comments are more your choice? Or
It depends. So typically I'll try and do doc comments. Like, let me try and pull up some code here. So like in Accelerate, we have this accelerator.prepare, which essentially wraps around whatever you're passing through to do what we need to do for getting it ready for any sort of distributed data parallelism and things like that. And so we have the doc string, right? And then we have the arguments here. And then we'll sort of have these tips in the doc string. And these tips can be just anything you think that a user would be good knowing when they're looking at the doc string. So usually, if it's something that's around the entire function, I'll put it here in the doc string. Or if it's like 1 or 2 things where if it's a nuanced behavior, but users should be exposed to it when they just highlight over the function, then we'll have it there. If not, we'll have the meta level comments where, we have, okay, look at enabling, tensor parallel training directly. So this tells me that, all of this code checks that we're doing tensor parallelism, and I can do something with this accelerate bypass device map to maybe enable it. That's sort of a meta level comment. And, we have more and more as we go by that explain in greater detail what certain chunks do, and especially the order in which they do it. So it's good to have both, but understand the audience of both, right? A typical user is not going to read this. Someone that's going to be investigating the code base, wanting to learn how it works, maybe open a PR, those are the people that are going to want these. So it's okay to have extra information in the doc string that could be useful. Just make sure that what's useful is good for a general user, and then power users can have the comment blocks down below, because you don't want to overload the user with too much information.
yeah, that's a good approach. Thanks.
No problem.
Do your comments there actually get generated as HTML somewhere?
Yeah.
I've seen that a lot with like NumPy where their stuff it looks like it's probably getting rendered as HTML or Markdown somewhere, and it's like I don't know where that goes.
Yeah, so the tip gets rendered here in the doc
Okay.
doc. And then if it's a
Gotcha.
warning,
Because I
it'll
always think
also
those
render
look kind of
differently.
ugly. I think those always look kind of ugly in the doc strings themselves when you're like just looking at it, in like Jupyter or something. But if it's like I always assume that they're getting rendered somewhere else, and it's like, man, that seems nice somewhere.
Break away from
Yeah.
Jupyter. It's a great thing to do once you've done it.
VS Code renders that properly. Is that what you're?
It doesn't render it properly, but it renders it better.
Okay.
In something that's like at least readable, because you can scroll through it, whereas in Jupyter, it kind of just shoves it all there depending on what you're doing. And
Yeah.
takes up a lot of space. So there's probably integrations that let you actually highlight certain things. I know that they do for like warnings and tips. But yeah, so that's what that winds up looking like. In terms of categories of comments, right? Because we already talked about like comments in the code versus in the doc string. So interface comments are ones that precede the declaration. So that's like something you put at the module declaration. So that's things that you put at the top of the file. Data structure member comments. So this would be like describing the arguments or describing the different parts of a data class. Implementation comments, which is the ones inside methods and functions. And then cross module comments, which is saying basically A impacts B. And B exists somewhere else. And then it talks a bit about lower and higher level comments and how low level comments add precision by addressing the exact meaning of the code. So in the earlier example, when we looked at accelerate, there was a 1, 2, 3, 4 in terms of a stepwise comment that explained what was going on. So that's adding precision by saying, here's what happens at these particular points. And then higher level comments enhance the intuition. They omit details by provide a better understanding of the overall usage of the code. And sort of doing so, you need to think about on the bigger scale, what is this doing and how can I document it better? Right. Prime example again, how we had the ABCD or 1, 2, 3, 4 in the implementation itself of prepare, but then we had that note in the doc string itself that talked about particular use cases that a general user would need to know. So then I talked about how do you document an interface, and specifically the documentation, because code alone is not sufficient enough for describing abstractions. Right? Again, fast AI, there's barely any comments in the code. And because there is such an uphill battle for learning that, we can then say it is not sufficient enough with just what is written. And so comments have to be used. Interface comments, which is abstraction definition. So those interface comments would be like your doc string, I believe in this case, is sort of the vibe I get off of it. Need to be separate from implementation comments, which is inside the function itself. And generally, those two should be disjoint. You don't just want to repeat something for the sake of repeating something. If you want to do that, then put it at the highest level possible for availability. So put that in the interface comments. And then interface comments should be for a class or method, should describe the behavior, arguments, return values, side effects, exceptions, and preconditions. Do your doc string well, please, for the love of God, is basically what all of this chapter is saying. For implementation comments, it gave us a general what to do and why. So they should help the reader understand what the code is doing, but not how it achieves it. right? It shouldn't say like, oh, we're going to call XYZ on the back end to do this, to do that, to do that. Just state, we are getting this result by passing these things in. And then for longer methods, add comments before major blocks or complex loops to provide higher level descriptions. A different way I think about that is if you have a super long method, right? Very good example of this would be trainer.train. I'm pretty sure that thing is like 900 lines of code at this point. Almost write it like an essay, right? Chunk it out, write comments for each part, so that way users can not just get lost in a million lines of code. They can go, okay, I'm going to focus on this part that talks about this part that talks about this part that talks about this. It makes it much more, what's the word I want? It lowers the barrier of entry to understanding what the code is actually doing, and they're not overwhelmed with everything happening all at once.
Yeah, the term you're looking for is, I think, lowers the cognitive load.
Thank you. Yes. You lower the cognitive load. Very good. Of your code. And as a result, users can actually understand what the heck is going on, versus without it, they'd just be lost. So with cross modules, generally it recommends using a central file to document cross module issues with reference to when code is needed. It says a central file. In our day and age, use a GitHub issue or a project or something, is kind of what I've seen. Because the next part of it is the challenge is, where do you naturally discover things like this? And when I was reading this chapter, I sort of thought about that, because you could put in the documentation, but the amount of people that actually go to the documentation is not a lot of people, right? If we're talking the web-based documentation, you could have a file on there and some users might find it, but the percentage of users that need it versus the ones that are actually viewing the documentation, only a small chunk of them will actually go look at the documentation itself. They'll generally stick to the code or immediately go look at the GitHub, is what I've found. This is a really neat experiment when I did a complete redo of Accelerate's documentation, because I noticed we were getting so many issues and a lot of them focused on certain things. It's like, okay, let's redo all of Accelerate's documentation, have it in this good organized fashion that I might cover at some point. It's a really good implementation system that we found, or a good design system that we found works really well for our users. However, the amount of questions that I got that still are just like, well, go read this thing of documentation here that we wrote. It exists and it has a decent amount of traction. I still hit an issue with that 1 or 2 times a week on the GitHub. So in my opinion, rather than having a central file, because when users use your library, they're not necessarily, you don't add a design notes file as part of your module, right? You add that in the documentation somewhere. So in my opinion, the best place for that would be like a GitHub issue, because then other users can discuss with it, ask questions with it, and it never has to close. It can just stay open permanently, and it's just there as a living resource. And because it's tied to the GitHub, users automatically know where it is and how it exists. At the very least, they can try and find it. Versus, if you have it on like a forum post or something, you're adding now a new cognitive load of, hey, your users need to know that these forums exist, and that might not be a thing. And then the number one rule that I've sort of taken to heart with the Accelerate documentation is, if anyone, be it a reader or a reviewer, finds something not obvious or confusing, that's not their fault. That is your fault for not giving a clear enough example, a clear enough documentation, And so your first instinct should not be to argue or to berate them or to say, well, it's just this. They likely have found that documentation, and clearly that documentation was not enough. So we need to go revisit why it was not enough. Was there too much fluff? Was there a higher cognitive load than a typical user would need, a higher understanding of what they need to actually try and read this documentation that could be lowered a bit? There's a million different answers for this question, but always run through them first when someone is confused on how something works. And if you've truly exhausted all efforts, explain it to the user and help them, and then ask them, how could we improve the docs for you to find this? I've done that with a few users, and they usually say, well, here's how I looked, here's where I looked, here's how I tried to find this, I couldn't find it. Now you have an exact step-by-step process this user went through, and you can then judge, okay, let's try and bring it to that first part they looked at. If we can't bring it there, we'll bring it to the second part. And now you've solved their problem. They feel empowered because their solution is now being added to the documentation, and future users probably can follow the same path and answer the same question without opening a duplicate issue. So are there any questions on chapter 13 before we go to 14?
What about updates to a module or a specific document? Do you have a process here at Hugging Face too?
In terms of what, like just general improvements?
For example, let's take this your AMP Microsoft AMP PR. So you
Sure.
would have to update your document with respect to how to use it with deep speed and how to run it. So might that have a documentation update as well?
Yeah, absolutely. So, well, deep speed's not quite there yet for the MS AMP integration. It's an MS AMP issue with not having a high enough deep speed. With how accelerates docs work, I'll try and find the exact term for the setup, but basically we have 4 different paradigms, you could say, 4 different sections for our docs: tutorials, how-to guides, concept guides, and reference. And so anytime we add a new feature, generally we try to add at least a how-to guide and a concept guide, or really a how-to guide and how-to guide and a concept guide. Reference should be along for the ride at some point. And so when I did the the Zoom stuff is just over my top bar. So when I did the MS AMP integration, you can see that I wrote a concept guide. I wrote a usage guide for it. And then I also updated the package reference guide that has any of the useful things for it. And so this is sort of how, if any feature gets added, we'll update it there. And then there's a file for deep speed. So I'll go through and update the deep speed file when that's enableable, and probably add it as well to the usage guide, just so that way it's in 2 places that users might want to look at.
Yeah, cool.
The only reason why that makes sense and why it works is because of this sort of separated out doc style, because the old one was kind of just throw everything together and it was really hard to navigate. And as a result, the cognitive load was huge. And anytime you added one little thing, you had to find like where in this book worth of documentation you can add your detail about that one particular feature. And that just didn't make sense, right? And I'm sure that's sort of what you were thinking as well. Like, okay, well, I add this one feature. I have to go try and find a good spot in the documentation that I can shove this thing. And we sort of take the approach of, well, if it's a big enough feature that needs to be stated more than just in the doc string, go ahead and write a concept guide and a usage guide for it. Each of them have predefined levels that a user is expected to learn, right? A usage guide assumes we're not going to teach you what's happening in the implementation. We're going to teach you how to use it and what it's doing. And then the concept guide tries to teach you some of what you need about the implementation itself, or what the idea is, or what's happening under the hood. In that way, users can sort of do a pick your own path of how much cognitive load they want, what they want to learn, how far they want to go into it without over exerting themselves trying to learn all this knowledge. Because we could, combine everything that's in this concept guide with this usage guide, but all of a sudden now they're like having to go learn internals of FP8 and how things like that work and how MS AMP works under the hood for a lot of things. And a general user doesn't care about that. A general user cares about, let me train my code and use this thing with the least friction possible.
Mm-hmm.
So that's sort of the main benefit that we've seen in implementing this practice. Because also if you update the docs, you don't have to go search for it. You know exactly what part you need to update, right? If it's something that a user wants to explain further as part of what's happening under the hood, okay, go check for a concept guide. If a concept guide's there, add a short sentence about it. But it doesn't have to go in the usage guide because a general user doesn't need to know about that.
Do you also have some charts for the memory savings here, or the
With this?
benchmarks? Yeah.
I need to run more tests. Generally, yes, you will see
Okay.
memory savings. I think in the PR, I show a table. I show a quick thing with my results. I saw a memory decrease of about a third.
Mm-hmm.
And then there isn't, the only thing with, while there's a memory decrease, the speed increase wasn't quite there. It was actually a speed decrease. But I need to do a lot more tests with that, and I just didn't have the time for it.
Okay.
So, good questions. Let's see, that is the wrong one. So, all right. With that, then we'll go ahead on to chapter 14, which was an exceedingly short chapter. And it's all about naming. So, good names can serve as documentation, right? And poor names, as a result, can do the exact opposite with cognitive load, right? If you have 1-letter or 2-letter variable names, those don't provide a lot of context generally, right? If I'm looking at an implementation of some function that just like counts cards, self.a and self.b don't make a lot of sense. Whereas if I was doing like Pythagorean theorem, self.a and self.b make a lot more sense, right? Because a squared, b squared, c squared. So it needs to have significance in the function itself towards what it's doing. And generally, you should always prioritize clarity over how long a variable name is, right? You could have a variable name that's like 24 characters long that says like value of B out of A. That's clear, but you can simplify that and just say result, and make sure that context clues exist to make sure the user understands what's happening in it. And so you have this balance of, okay, well, I can't really do 1 letter or 2 letters, but also too long, it gets repetitive and it's not actually useful for having such a long variable name. What it recommends is create an image in your head of, okay, if I'm a general user and I have some 2 things that go in, what probably would I want to name them? Just describing what they do and what they represent. And that's without seeing anything about its declaration or its usage, just simply in, say, like the function definition. If you have that image, go with it. If there's a count words method, what probably am I going to want to name the variable? Words, right? Because I'm going to pass in words to count the number of words in there. Simplistic, but can impact your readability, can largely impact your readability. Working on it. And then it generally has some advice for red flags. So in this case, you can start with like a very large complex name, and then as you're simplifying it down more and more, if you can't find a clear way to name something that isn't like within a word or two, there's probably an underlying issue with what's going on, and it might be doing too much. Because if you can't find a simple way to just call it something, then there's not a simple way for a user to even understand the context in it. And then generally it talks about extra words and readability, which I sort of touched on. Every word should provide usefulness. Unnecessary words add clutter. So avoid generic nouns like field or object because, well, that's already what we expect. Give me something new about it instead. And then the other very, very clear distinction here is readability is not judged by you. Readability is judged by your readers. So if users are using your code and they're complaining about cryptic variable names, cryptic code that's happening, try using longer names, because as the distance between a variable name's declaration and its actual use, you exponentially decay the amount of information that a typical user's going to remember about that thing. So you want to try and keep that link for as long as you can by using a good name. Any questions on chapter 14? All right, cool. And we will chug along to chapter 15, which is write the comments first or use comments as part of the design process, which personally, I do this quite a lot. The best time for you to write comments is when you're starting to implement something. Use it sort of as a rough draft of, I expect things to operate in this fashion. The first part about why that can be bad is a very easy habit we have is, oh, I'll document it later. I'll write comments later for it. We'll deal with it. What winds up happening is because of how fast we're iterating through things and working in general, we're not going to ever get to that. And the longer you leave it alone, the bigger the procrastination feels. It becomes less and less appealing. And then a strong likelihood that documentation will never be written. So that's why whenever, for instance, when I implement anything in Accelerate, if it's a new feature, such as in that PR, I don't do a small PR that's just the code. Ever. I try my hardest not to. I try and write the document. I write the source code and the documentation all in one go, because that way, let's say I only have 3 days to work on this thing, and I've spent 2 days implementing. Rather than finish early, I'll spend that last day writing the docs, because that way I never have to touch it again, right? If all goes well, I never have to touch that docs again. Users can know how to do it, and everything works. But if I don't, 6 months down the road, I could be sitting there going, oh shoot, I meant to write docs for that thing. And I've not only added some technical debt, because now I have to go through and write docs, I've also lost all of the context I had when writing that implementation. Those particular structures that I learned when writing it, and those little tips that I had that I could go in documentation now aren't there. So it has some general guidelines for when and how to write comments first. So for a new class, begin with the interface comment or the doc string. And develop interface comments and signatures for the crucial public methods first, leaving the bot method bodies blank. So this is like during your design practice. I don't fully do that, but one thing I have wound up doing is I have a plugin in Jupyter, or not in Jupyter, in VS Code. It's called Auto Docstring. And basically you write the start of a block comment for the docstring and then hit enter, and it will take all of the types and input names for your function and populate a docstring for it. And so that way, the second I finish the function signature, boom, I can just go through and fill the things as needed that I believe it should happen. And then I can just work on the interface itself, and there's no risk of, I'll write the docstring later. I don't need to document these things because it's internal stuff. It forces me to sit there, do it, because no matter what, it's going to be useful to someone. Generally, then it recommends iterating over those comments until the basic structure feels right. So as you're writing down, well, it should work like X, it should work like Y. Narrow it down further and further until the overall structure makes sense. And then add your declarations, basically write your implementation. And starting with the comments and ending with comments and code. I don't fully do this. I don't do this step of iterating over my comments. Generally, I just write the comments and then write the code with it. And then as I write the code, if there's something that's unclear, then I'll write the comment. But otherwise, that's generally how I approach things. So then we talk about comments as a design tool, right? So we talked about earlier, they're essential for understanding what abstractions are doing. If you wind up having long comments or long chunks of comments, there could be issues with the abstraction or decomposition of what you're doing. The interface might not be simplistic enough. The key word there being might, right? And may. Because a long comment isn't inherently bad if what you're doing has to be a complicated implementation, right? If you're writing, even earlier, we had that 1, 2, 3, 4, and a large comment block describing a chunk of what prepare is doing. We can't abstract that further because we're using code that's already abstracted. It's using some other library stuff. I can't abstract it more. I can just say what we're doing, or abstract it less. So it's not that long comments are inherently evil, but if you're writing long comments, consider whether there's an issue with the abstraction, if it should be documented in the documentation itself, be it either in the doc string or in the docs, and sort of just come to a conclusion of which is probably more valuable. Is it good information for me to know or good information for a general user to know? The best classes are simple interfaces that implement powerful functions, so do a lot of things, but have evidence of this in the quantity of their comments, right? If we have a ton of comments for simplistic functions like trainer.train, if there's a bunch of comments explaining what all the code is doing, then we have a powerful, simple interface with a powerful function. It's doing a whole lot of things, and we're doing our best to be able to describe to the general user what these things are doing. And then if you ever can't fully describe what's going on, probably something wrong with your implementation. So the general red flags that we look for that I mentioned, long comments for a method or variable is a red flag, possibly a design choice. And then hard to describe comments probably means we have a design decision issue. It sort of talks about how then writing comments generally first leads to more stable abstractions, and can save time during coding because usually then you're thinking about the interface before actually writing the code. You're not doing a full write it twice, but you're thinking about it before actually writing it. So in my head, I count that as thinking about it twice, which bare minimum just means you've iterated over it and you've thought about it in more detail. Any thoughts or questions on chapter 15? Or stories of where that actually worked? That's all right. Then we'll jump to the last chapter for the week, a very short one, chapter 16. In terms of how do you go about modifying existing code? So we want to stay a strategic programmer, like it sort of talked about in the beginning of the book. We want to produce a good system. And a good system makes sure that it's easy to maintain and enhance. It mentions that we should aim for the structure to align with the design and consider if the change and potential future changes were considered at the start, which is a bit weird to say, right? Because we're considering like, okay, well, if I have to rewrite this entire class or rewrite some of it, I should have thought about that months ago. And that's not easy to do, easy to think about. The way I tend to think about that comment more is, okay, if I were to wrap around that class and use it as a base class to implement something new, how easy is that to do? How flexible is that to do? Right? How easy is it for me to wrap around the trainer and use my own metrics implementation or my own forward pass implementation? How easy is it for a user or me to go do that? If it's easy, then that's good. That's how it should be. If it's not, then a refactor might be needed. And we might want to expose certain new things and think about, well, okay, if we refactor this, certain parts might be easier, certain parts might be harder, and do those easy parts outweigh the harder parts?
One thing that they talked about in that first section in chapter 16 is changing, like not changing the minimal amount of code necessary to like make a change. I feel like that seems very difficult to do in like an open source project, to especially if you're not the like core contributor or one of the core contributors on the project, but you just like come across an issue and it's like, all right, I'm gonna go fix this thing, whatever it is. And you get into the code and it's like, oh, I see some other things that I should change too, because they are, more complex than they need to be. Like, I feel like most core team members of an open source project are going to shut that down.
Yes. That's exceedingly accurate. And that's for a good reason. We just had a case of this at work where someone noticed that we were doing a lot of repetitive things and wanted to like chunk out the trainer.train because it was 900 lines of code, and they're like, well, okay, but this is hard to read, let's split it up. And we had to immediately shut that down because it's long for a reason. If you're a non-core contributor, if you see something like that, rather than spend the effort and do a PR, open an issue first. Just be like, hey, I noticed these patterns. Does it make sense to abstract this out? Have you guys thought about this before? And if so, what do you think? Because more likely than not, we have, and we can tell you why we have. Or if not, which also happens, then we could say, no, we never thought about that before. Would you like to do a PR for it? Because you're already thinking about this well ahead. The amount of times that's successful versus not is like a 30-70, I'd say. But that 30% is exceedingly valuable because it brings in a new perspective that when we get into the weeds of things, we just skipped over. But yes, it is definitely one of those things where if you're a non-core contributor, it's harder to pull it off.
You almost have to be tactical. And I feel like it's really hard to not be tactical if you aren't like the one making the design choice of the library, or at least like the functions that you're playing around in. Like if you aren't the one that wrote it, it's hard to be like, hey, went ahead and rewrote this function to be more strategic. Like it's simpler, and then it's like, okay, but does it actually, like, does it break something else? If you have good tests, you should be able to tell. Like that's, I feel like from a core contributor standpoint, you should be like, if we can't trust our tests enough that we can make a change like this, then it's that's a testing problem. But I could also like, but also tests aren't 100% typically.
Yeah, we've had that a few times in Transformers, and if there is something big like that, because we have Transformers, like one of the most test libraries I've ever seen and worked with. Generally, we'll say, like, if it's a big change, okay, it passed this. Do you have a GPU? No? Okay, I'm going to go run it on our GPUs. We're going to run through the entire test suite and see what breaks. Because 99.9% of the time, it will find that thing that it broke.
Right.
And
I mean, I do like the mentality of that, of like, if the tests pass, then it's good. And if we figure out later it's not good, it's a like, what test should it have broken that it didn't, and why, like what test do we need to add so this doesn't happen again in the future, and it like tests for that situation or scenario.
And like even then, sometimes it's not perfect. A very good example of this is, and this is coming from me, a core contributor, when we integrated Accelerate into the trainer, the trainer has something called set epic on data loaders that sets its randomness to a particular additive, right? So you change the seed ever so slightly to tweak what epic you're on. Accelerate didn't have this. And so for a while, we had a test that was failing because it was for that test on the trainer's version of the data loader. And so for a few months, it was failing on Accelerate. And so finally, I was like, okay, I'm going to look into this, and we're going to implement this set epic thing inside Accelerate so we can set the randomness on the random sampler, on data sets, all of it. That worked. And then come a month later, I now have 2 or 3 issues open in Accelerate of, hey, the data loader changed. That's fine, but I'm training worse. And all of our tests were passing, right? I fixed that test that was failing in the trainer from before, but now my users are reporting, well, that's fine and all, but my accuracy's worse on the same seed. So like the tests were there, the tests were fine, and it worked, but without the user stories as well, I would have just assumed everything is fine. And now, like,
Yeah.
next week,
and how do you test that? That's a really hard test.
You
Like,
can't.
yeah.
You can get as close to end as you can, but like, I knew the shuffling algorithm was different. I knew we had to modify a bunch of different tests and slightly tweak their thresholds. And every single one showed improvement, which is why we went ahead with it.
Mhm.
And it's, you know, there's 16 different scripts that run for different use cases. Plus you have the actual tests themselves for the trainer. And all of those were showing improvements. And so we tried our best to test for it. I worked a lot with code, worked a lot with different scenarios. But because of this now, it's like, well, okay, there are just some things you're never going to be able to test for and never be prepared for.
Yeah. And I mean, some of that could even be like, if you were changing some of like how the random seed setting worked on your side, it might not actually be performing worse overall. It might just be that the sampling that they ended up with made it fluctuate enough that it's like, yeah, you're going to get different results, but it's still like it looks worse on that specific seed, but it's not like it may or may not be an actual problem that's like giving you worse overall results. It might just be because the sampling changed. If you changed from 42 to 43 for your seed, like you might get better results. I don't know.
Yeah. Yeah, and that is a key part of it. And I've sort of wrestled with that because yes, I can just say like, well, that's what the new sampler is. But I know
Yeah.
what my user's going to say. That's not good enough. I don't want to use
Right,
that
it's
sampler.
worse.
Yeah, if it's worse,
Yeah.
I don't want to use it. So now it's like, well, okay,
Maybe make it optional or something. I don't know.
that's exactly what I'm doing.
Yeah, that's
And
Yeah, how
by
did you fix
default,
that? Yeah.
and by default, it's going to be false. The new implementation. Because if users are complaining about it, okay, then we won't make it true by default or true by default. We'll make it false and then say like, okay, if you want absolute reproducibility, set this flag to true. You will see different results from what you had before, but it
Yeah.
will be exactly reproducible
well,
between runs.
one thing you might be able to do there is like run it multiple. Well, if you run it multiple times with the new version, it should be the same every time, right? Like you should
Yep.
get the same results. And on the old version, it would be different every time.
It'd be slightly different. They'd be close,
Slightly different.
but not exact.
Yeah. Okay. Yeah, that's interesting. Because I'm just thinking like you could, run it like 5 times and get a average with a range. Then you could kind of say like, yeah, you're fluctuating between these values. Is it actually, I don't know, almost run like a statistical significance? Like, is it
The
different
results that I
enough
saw
it
in the
actually
issue
matters?
were like exceedingly significant.
Oh, wow.
Like
Okay.
the prior version, like you have an ending loss of 0.3 or like negative 0.3, and the latest version was like an ending loss of like 4 on a scale that everything should be sub 1. We're like, okay, that's significantly different. I cannot just say
Yeah.
they're close enough. That is not close enough.
Yeah. Yeah. That's
So,
interesting.
yeah, the things that you find. And these are the ways that like a bug stays a bug for ages and everyone just accepts like, yes, it's a bug. I tried fixing it. Everyone yelled at me. So it's here optionally. But we know it exists and we know it's a thing. I mean, I guess we can kind of end it there because the rest of it is just talking about like you should generally refactor. The long-term benefits of refactoring generally are good. When refactoring, make sure to prioritize code clarity over implementation details because otherwise, why are you refactoring? It should make everything simpler. If it doesn't, don't refactor. And that's roughly it. The last little part was put comments in the code, not in the commit log, because people aren't going to remember the commit log. Especially if it's a code base like Accelerator Transformers, we squash. So your commit log is like going to be lost to a certain extent. It'll be in there, but like it won't be in the main commits. We have to go look at the PR and look at everything. So write your comments in the code. Don't write them in your commit logs. It's handy for like local based things and like saying, I'm trying this, I'm trying that, but don't use the commit log as your documentation. So that's
Kind of
all I
seems
got.
fair anyways. You shouldn't rely on the commit log because it's not like it's so decoupled from the actual code itself.
Exactly. Like, don't write poor commit messages. Make sure you're using commit messages for the sake of commit messages. Like, use them as bookmarks. Don't just say like A and then push, because I have no idea what A means. But also, yes, don't rely on them in documentation. They're not meant to be that. So
I had one other so kind of back to the variable naming chapter. I was doing some work in Fast AI. I was looking at the test library. It's like I think it's notebook 97 or something.
Yep.
And I noticed the synth debunch
Mhm.
has two variables called in_train, TRAIN, and invalid, like the letter in_valid. And synth learner, I believe, has in_trn and in_val. Like it has it's like the same, and it passes from one to the other. I was looking at that after I'd read that chapter, and it's like I think that's the keeping it consistent of like that should be train all the way through or TRN all the way through, so that you
Oh,
like
It's even more
know
than
that you're
that,
passing the correct
right?
things.
First, there's the variable names. Also, we haven't called it a data bunch in 3 years.
Yeah,
It's been
yeah,
data
that's fair
loads.
too. Yeah,
So yeah, it is
I-
little things like that where as you abstract more and more and you write more and more things around it and lose the one centralized place for it, risks like that can
Right.
happen.
I feel like I pick on the Fast AI library more than other libraries because that's like I'm in there a lot more, so I see stuff, and there, I mean, there are plenty of examples in there of like, oh yeah, that's against kind of what we're talking about in for like traditional software, not even traditional, but like software engineering principles. It just does things
Yeah, I mean,
poorly
like,
or differently.
yeah, I pick on the FastAI library throughout this whole thing because, in a way, this book is the antithesis to FastAI because it is the
Yeah.
antithesis to clean code, and FastAI was built heavily influenced by clean code. The book, you can see it everywhere.
Mhm.
That doesn't necessarily mean it's bad. It's just a great example for us to look at things because it's hard to come up with ideas of like, well, what does that actually look like? Well, here's a library that doesn't do these things, and you can see like you can actually see the results of like, well, okay, some things about this are easier, it has a good interface, but some things about it are harder, and that's not inherently bad. It's just a great teachable moment for us.
Mhm.
So, all right, we will take a break next week for Christmas. Tentatively, I should be good to do a lesson around New Year's because I don't think I'll be driving back until the 3rd. But keep an eye out for it. Regardless, whenever we meet next, be it on the like 1st or 2nd or on the would that be the 9th, get through the rest of the book and let's finish this thing because there should only be 5 or 6 chapters left. And come up with ideas of what books you guys want to read next that we can sort of talk about and go over. Generally, in the realm of software, is sort of what my thoughts are. Like right now, I'm reading a book on how to become a good manager if all you've experienced is software engineering. What does that look like? So it's been a book that's been pretty good so far, but think about what books you want to read. I'll throw some ideas also in the chat that we can think about. Try and make it about the same, I think, because we spent, 2 months on this book, give or take. And that's, I think, a decent pace for now. But yeah, thanks for coming, everyone. And I'll see y'all in the new year.
That's
you,
good.
Zach.
Thanks, Zach.
Bye, guys.
See you, everyone.
See ya.
Thanks, Zach. Take care.